wondered how Netflix delivers your favorite movie or series without any lag? In this video, we'll be discussing about how Netflix streams video globally without buffering. A ton of architectural brilliance happens behind the scenes, and Netflix does this beautifully in layers. But before diving into the layers, let's understand the scale at which Netflix operates. Netflix operates in 190 plus countries. Netflix said that it crossed 325 million paid memberships, 191 billion hours watched across 2025, meaning about 523 million hours watched per day on average, which means 22 million concurrent viewers globally across 2025 itself. And some major events like Jake Paul versus Mike Tyson, etc., peaked at 65 million concurrent viewers globally. You know the scale of the system that we're talking about, right? Isn't it interesting? Let's start with the first layer, which is Netflix stores multiple versions of the same video. Well, why does Netflix have to do this? There are two reasons. Firstly, internet is never constant, right? Sometimes you have a high speed internet and sometimes you have a low speed internet. So Netflix stores multiple versions of these videos, say 240p, 360p, 480p, 720p, 1440p, 2kp and 4K pixels, so that it can deliver the media to you based on the internet speed. And the second reason being is the world is full of different kind of screens, right? We have phone, iPad, laptop, TV, car displays, smart fridge displays, even watches, etc. For example, sending a 4K stream to a device which is say of lesser resolution does not really make sense, right? That device cannot fully benefit from all the pixels that is being sent, so all of that extra data or overhead would produce in wasteful bandwidth and also extra data. So having multiple versions helps Netflix in these two ways: your internet speed. Coming to the next point, each of these versions are basically encoded with codecs like AV1, H.265, etc. to ensure best compression. So codecs are basically used for compressing the video. So Netflix invests heavily on these codecs, and codec is basically this technique used to shrink the video size so it can be stored and streamed efficiently. Different codecs compress the data differently and on different levels of efficiency. So the same quality, one codec might need less data than the other, and the current codec technology that Netflix uses is AV1. As we move further in this video, I'll explain how Netflix automatically switches between these resolutions based on your internet speed. Coming to the second layer, Netflix slices video into chunks. So instead of streaming one huge file, it cuts the huge video into segments. So why does it have to do that? A movie file is huge, right? So a 2-hour movie of 1080 pixel can be around 3 GB to 8 GB, and a 4K movie can range from 15 GB to 50 GB, which is huge. And Netflix does not send the entire movie to one big file. So if Netflix sent this entire huge giant file at once, then the user would have to wait until the entire data is arrived for him to start the video playback, which is a very bad user experience. And if the user has to wait for more than a minute to watch the time, then it's bad, right? So your device can do something like download chunk 1, start playing, and then meanwhile you're downloading chunk 2 and chunk 3 and chunk 4 based on your internet speed, and this is basically called as streaming. So basically Netflix does is it cuts this entire video into segments of around 2 to 4 seconds, and each of these seconds has multiple quality versions that we talked about in the first layer. So each of these chunks has all of these different kinds of resolutions. We talked about how Netflix slices the videos into chunks, and also how it stores different resolutions of the same video. But how does Netflix really understand as to which encoded version to pick when the video is being played? That particular technology itself is called as adaptive bitrate streaming, and this technology is also currently being used by multiple big tech companies which do streaming. For example, YouTube, Hotstar, etc. So this is typically implemented using protocols like HLS or MPEG-. So there is something called as a manifest file which tells exactly which chunk versions are available and at different qualities, so that the player can decide based on the network conditions as to uh, which version and which quality to pick. So basically, Netflix keeps monitoring few points. Like for example, it keeps monitoring how fast our current bandwidth or internet connection is. It continuously monitors the download speed of our recent chunks and also the current device that we are on. So let's take this example. Say you're watching a series and you're currently at the time frame of 1 hour and 10 seconds and your current internet speed is around 2 Mbps. And as you're progressing through the series, your internet connectivity drops to say 1 Mbps. Then Netflix automatically monitors that your internet speed fell, so it delivers you the lowest resolution chunk, say 360p for this one. And as you're still progressing, say your internet speed is now high, it is around 10 Mbps. So in that case, Netflix delivers the best resolution content chunk for you. Similarly, as we progress through the video, same thing happens. It monitors your internet speed and delivers the chunk that best suits that internet condition. Coming to the fourth layer, let's understand how Netflix leverages CDN to deliver content. Let's take an example. Say Netflix wants to stream data without CDN. The video would have to be streamed directly from the origin server to the destination. Say for example, Netflix servers are in New York and you're sitting in Bangalore, then the content has to be served all the way far away from New York right to Bangalore each time. So in that case, you would see noticeable delays and also increased latency. So what does that mean? If there are noticeable delays and increased latency because the server is very far away from your location, then this would cause potential buffering, which is lag. And if there is buffering, it is going to cause bad streaming experience, hence bad user experience, right? So let's go with another example. Imagine McDonald's has opened its first ever branch in Bangalore and it's serving burgers and fries and people are loving it, and suddenly it becomes internationally popular. So how would you deliver these food items internationally? There are two options, right? Say the first option would be delivering internationally. What are the downsides? If you're delivering the food internationally, first of all, your food cost is going to bump up as well as the transport cost. So the customers would have to pay both the food cost and the transport cost, which is very expensive and definitely not sustainable. And if you're transporting it right from India to say New York, it's going to have a lot of transportation delay as well. So the user would be receiving food maybe after a week, which doesn't make sense, right? So what's the second option? The second option is establishing a local branch in that popular location. Say New York is gaining traction from this popular food item that you're serving, and the upsides, and if you're going to set up a local branch right in that popular location, then you're going to have a setup cost, which is fine, but the food is going to be readily available, it is cost effective, and also a perfect long term solution, right? That's exactly how CDN principle works. So CDNs are nothing but geographically distributed cache for static content. Say instead of serving the data right from the origin server, we'll be serving the content from distributed cache servers which are situated in multiple regions globally. So how does this help? This helps in faster content delivery, reduce load on the origin server because each time you'll be querying the cache server, so this in turn brings lower bandwidth cost and also improves reliability and also better security, right? And CDNs comes in two types. One is that of a pull based CDN and the other is a push based CDN. Pull based is usually the standard way. Let's understand how pull CDN works. Say you're the user and you are querying an image. So it first checks your CDN, say it is located in Bangalore, and your CDN does not have the image. So what does it do? The CDN asks the server, does it have the image? Then the server responds, yes, I have the image, and then the CDN gives back the image to the user. And say your friend requests the same image now, and this time it hits the CDN again. So this time the CDN will have this content cached in its server, and the next time it serves the same image through the CDN. So this time it does not query from the origin server. So the load on the origin server is reduced this way. So every subsequent request that are coming after the first time is going to be cached in the CDN and will be served right from the CDN itself. Coming to push based CDN, the typical model that Netflix uses to cache in their CDNs. So let's say Game of Thrones is going to release on Netflix tomorrow, and you know that it is definitely going to explode. So what would you do? Would you wait until the user requests the CDN and then the CDN goes and fetches to the server and gets back the movie like we did in pull based CDN? No, right? So that's exactly what Netflix principle behind this is. You upload the content, Netflix uploads the content to the CDN before anyone even requests it. So this gives higher control, and this is usually done when you can already predict the demand beforehand. So it preloads the popular movie or content to the edge servers during off-peak hours, so playback is consistent and is pretty instant for the users. Initially, Netflix operated with third-party CDNs like Akamai, etc. But as their scale grew, they realized that that was pretty inefficient, so they built their own CDN called Open Connect. So normally when a user requests a movie, the content has to travel from the origin server to the CDN node over the internet, and then to the ISP, and then to the Wi-Fi router, and then to the user, right? That works, but for a company like Netflix, which is operating at that scale, the traffic volume is so huge that this traditional thing becomes very expensive and inefficient. So instead of depending on traditional ways, Netflix built its own CDN called as Open Connect. Why? Because they realized that building their own CDN turned out to be much cheaper and much efficient for them instead of using third parties. So at the heart of it, this this Open Connect CDN that they built is basically nothing but a hardware appliance called as Open Connect appliance that they built. So it is basically nothing but a Netflix owned cache server, and this is placed usually inside the ISP or near the ISP. So let's understand the high level flow of how Netflix delivers content. So when a user presses play, Netflix first figures out which nearby OCA it should serve the request from. So say it has a list of OCA URLs, then it fetches the OCA URL which is nearer to the user. Then the video chunks are delivered to that particular OCA which is near to the user, which is then served through the ISP directly to the user. This means the content does not need to travel across long internet paths, right, every single time. Instead, it is just served from a place which is much nearer or closer to the user. And this basically reduces the backbone traffic. It also reduces and gives a lesser bandwidth, and also most importantly it reduces buffering, which is what we were looking at. While I was talking about pull based CDN and push based CDN, did you wonder how cache invalidation happens in both types of CDNs? So basically in pull based CDNs, we usually rely on TTLs, and updates usually propagate after expiry or manual purge. But in case of push based CDN, once you realize that the content that you're streaming has exploded and is now bearish, so in that case you purge the cache when the content changes, because CDN cannot refetch on its own, right? That's why. So I hope you enjoyed this video. This comes to the end of how Netflix delivers content without any buffering. I hope you like it. Like, subscribe, and see you in the next one. Thank you. Bye.